In the previous classes, we have seen set interface and list interface and respective classes, and we have seen some examples as well, right? So here we have some, so we are going to discuss as part of today's class is a map interface. So the map interface is, it is not extended, it is not from the collection interface. It means that it's not extended the collection interface, and the collection interface has a separate functionality and map interface has a separate functionality. Like your collection interface has the, like for individual individual objects, like you can add objects, you can remove the objects, and there is no linkage there. Link in the sense, let's say I want to maintain some reference for each object. I want to maintain each reference for each object. What are the object you are putting there? I want to maintain such a way that key value pair. Let's say my collection, my collection should look such a way that I have some key which is pointing out to specific value. My key can be object, or my key can be object, or it can be primitive. My value can be object, or it can be primitive. So I want to refer, I want to some kind of key references. Like I want this, if I try to access this, it should be available with my, so where I want to key value pair kind of data structure, the collection interface is not suit there. So that the collection interface has a different functionalities where you can add a single data structure, single objects. So but when I need a collection type of data structure, where is a key value pair data type structure, I have a different kind of map, different kind of interface, which is that it's a map interface. That's the reason your map interface is not from the collection interface. So in this collection interface, you have a methods for put the single element without any linkage with other key. You have a add all, retain, clear, that kind of methods are there. But map interface does not require that type of things. So your map method is always referring key value. So if you don't have a key, there is no point to have a value. If you don't have a key, there is no point to have a value. Without value, there we can have a key. The value can be null, but at least we can have a key. The key is the most important part in this mapping, in the map interface. So that's why the map interface is a separate interface. It's not part of your collection interface, right? So when you want to maintain any data in the form of key value pairs, we will go with the map interface. So in the map interface, you have methods like a put and get. Put, there is a method called put. I'm showing very high level here. You have a method called put, where you will specify key, and you have a method and where you specify the value, and you have a method called get, where you will specify the key and it will return the value, and you have something called put all as like add all, where you can add other map into this, right? You can also check whether the key is so here the main, who is the total dependency is going on the key. Like based on the key we will be fetching the values. We can also check contains. There is something called contains method which says, which contains key. Okay, you can specify whether the keys exist or not. If the keys exist, you bring the value, right? These type of methods are available in your map interface. To see more detail, we have a document, right? That, what is the document, where is the document is released by these guys. Let me open this document. Yeah, this document. Yeah, go to retail package, but it is under retail package only. But it is not extended. It's not extended your collection interface because of the way it looks, the way the data will be. So you can go here, map interface, click on the map interface. So you can here where you want the key value pair type of data structure, we will go with the map interface, right? Look at guys here. There is some nested class called map.entry set. Entry map.entry. I'll show you that what is a map.entry later. We have methods called clear, contains key, contains values. We are checking whether the keys exist, the values exist in the map or not. If the keys exist, go and get it. You can use the by get method. Entry set, it will give all the set of keys. Sorry, entry set is something like it returns the set of view of the map, set view of the map. So we have seen the set view right before, the set interface, that kind of thing. Okay, and equals get, you will pass the key and it will give the value. And hash code, you know what is a hash code, and is empty, you're checking is the map is empty or not. And a key set, this returns the key. Okay, sorry, key set, this returns the key, all the keys as a set, all the keys as a set. Okay, and put method, put all method, put method is putting the data into the map. Put all method is if you have already a map is exist, you want to put into the existing map, you can put. Remove method is for removing. Size, it will give the size, and values, it will give all the values, all the values, it will return all the values. Let's look at a simple example how the map interface works. And the map interface, there are the few classes which has been implemented the map interface. The classes which are implemented the map interface, those classes are Hashmap, Hashtable, linked Hashmap, Treemap. If you see linked Hashmap, guys, it is maintain the insertion order. Tree means whenever you see a tree, it means sorting. Very simple. Hash linked means maintains the insertion order. Hash table, I'll talk about that. Hash table is, we will see detailedly. Hash table is a legacy system like your vector. Vector is there till from 1.2. At the same time, the hash table also was there in the old days. So that all the methods in hash table are synchronized for the synchronization. Hash map, it maintains the value, it maintains the data in the key value pair. It maintains the data in the key value pair, and it will not be having order, no order. So we will be seeing them, and as an example, let's look at here. I'll explain each and every class, not to worry. So I'll explain each and every class detailedly. Let's start our Eclipse. In this case, let me remove this from my launcher. I don't need this. I don't need this. I don't need this. It's becoming slow. My machine is becoming slow due to so many things are running. See, it's become slow. Okay, let's discuss about the map in more detail, and let's see a simple example by the time it loads. How we will create a map and how we will create this. So you will create a map as similar as your array list or list. Let's say map, or you say hash map, and you can give what is your key type. We have seen something called generic. Okay, so my key type is integer and my values are string. You can give like this: key comma value, int comma string, and the map name is, you say, id name or id map, whatever you want to say, and equals to new hash map. You have to specify here also id int comma string. Now id map dot put id map dot put, you will specify some number here, one, let's say 1 java dot put 2 comma j to e, as simple as that. Okay, put, so I'm just checking continuation, put 3 comma hadoop, put 4 comma spark. So like this you will keep in the map. So here, as I shown the before methods, let's say I want to check whether my keys exist or not. What I will do, id map dot contains key. I'll pass the key here. I want to check whether the fourth key is available or not. So it will return true or false. If it is exist, it will return true or false. If it is true, I can go here inside. I can either fetch it dot get. Get is the method to get the value. Get is the method to get the value. This guy will return the value. So we can store this value into somewhere else in the string s or somewhere, right? So the get method is to get the value. The put method is to put the values into map. Suppose you want to traverse through a map. Let's say you want to traverse through a map and value by value, and you want to print it. And you have something called for each loop here. You have something called for each, same as your for each, but here you need to specify map dot entry. Map dot entry. Actually, this, what is this map dot entry? It is a sub interface or subclass of your map interface, sub interface of your map interface. What is the inner interface? I can say I have interface map. In this I have one more interface, that is entry. Suppose if you want to call inner interfaces or sub interfaces, what you need to do, you need to you need to call with outer. This is called outer, this is called inner. Outer dot inner. So even inner classes also the same way. So that's why I'm calling map dot entry. When I say map dot entry, the map dot entries gives you each entry wise. Map dot entry gives you entry wise. We are representing this entry. What does it mean? I'm representing this entry. So you say m, because it's a map, colon, what is your map name? id map. id map. Here id map dot, what you will do, entry set. You need to get each set, no? You need to get the each set, no? Entry set. We'll traverse through like this. Let's check whether, yeah. Oh, actually it's running. That's the problem. So ours was Java hands-on. Look at here. We have seen collections, and in this we're going to see map demo, and I'll show you hash map with the employee. Guys, all the collections, not only storing, not only storing, not only storing primitive data types, it will also stores object types. In the real time, everything is an object. We will store everything as an object only. We should be very careful that. Anyway, I'll show that. Okay, so not to worry about it. This is. Let me close other. Let me clear my memory. If I close others, at least the memory will be free. So, yeah. See here. I'm going to show a map demo. You can create a hash map equal to new hash map. So let's forget about the other four. We will talk about that. Also you can create map a hash map equal to new hash map. Why I'm creating like this? Your hash map is a child of your map. Even list also same, guys. Your list has array list, linked list, vector like this, right? The same way your set also has the hash set, linked hash set, tree set, right? You have that way, right? I have arranged due to something, it's right. So these are all parents. List, set, map, these are all parents, and your array list, hash set, hash map, these are all childs. So the childs can be referred using parent. If you guys remember dynamic polymorphism, we are talking about, when we are discussing about a dynamic polymorphism, I have shown you your base class B can be new subclass, right? The same way here, hash map interface is a parent class. A parent interface is reference is storing, or is referring child object. Hash map is a child of the map, right? So if you look at here, hash map dot put one Ravi to. So here both are integer, both are strings in my case. I have taken both are strings. So we can string here. So look at, guys, here, string. So that's why I'm storing into string. And what is the functionalities of the hash map? Hash map, whenever you look for the hash, guys, very simple one. Whenever you say hash, it maintains the internal, it uses the hashing mechanism, hash code mechanism. It means it'll allow the only, it will not allow the duplicates, it allows only unique values. What is the unique value here? Unique values in the sense, our whole functionality as of now, as I discussed before, most of the things are depends on the key here, right? By key only you are fetching the data, by key only you are inserting the data. The key is a more important role is playing here. That's why we're calling as a key. The key is a most important here. So my key should not repeat here. My key should not repeat. The keys should be unique. The key should be unique. It means, it doesn't mean that if you put one more one here, it doesn't mean that it will break. It will allow. What it will do, the old one will be replaced with a new one. This one will be replaced with a new one. It will override, it will overlap the, no, the override with the existing one. It's overlap with the existing one, right? You can write in your code any number of duplicates, but while you are accessing, it will give only uniqueness. Look at, guys, here, hash map allows the null value. It doesn't mean that other not allow. Yes, others will not allow. Hash map will allow as a null, mean you can have a null value, null key. You can have a null value or null key. You can have a null value, either null key. Look at this here. I have already executed this example and I have commented. Why? Because I'll show you why I have used. Because below I'm using the tree map. So tree map will not allow the null keys. Tree map will not allow the null keys. Okay. Look at, guys, here. So it doesn't mean that if I say one more 1 6 here, saying that 2, will it fail? No, it will not fail. Why it will fail? It will not fail. It will not fail. Right? Because what will happen? The old one will be overridden with a new value. The old one will be replaced with a new value. That's the only difference. That is the only difference. Okay, so let me write one more method that makes you I think very much clear. Let me write one more hash map, one more map. So I'm going to write hashmap demo. Hashmap demo. I'm giving a name as 630. Can I give a name as numbers? Yes, we can give. It's not a problem. We can give. Okay. Now here, let's create. As I said, your map interface can refer child interface. So here I am doing that because in the real time we'll be doing with we are not tightly coupled with a specific type. We always go with a parent type. We always go with we'll always refer with the parent type. So we have already discussed about the dynamic polymorphism. That's the reason. So here I'm going to say int comma string map equal to new hash map int comma string. So what is this errors they are showing it is? So whatever you're putting into your collections, so internally to what it is a objects. So you have to use integer. Sorry, you have to use integer. So let's go with the respect to. You have to import the respective classes. Map. I have imported. So let's go here. Map dot put one Java. Map dot put to J2E. Map dot put JDBC. I'm just putting some random values, guys. Map dot put Hadoop. Map dot put. Again, I'm putting. Let's say let's put this one. I'll insert other value later. How it works internally? Internally, it maintains the linked list. I'll tell you that what is how it will maintain the linked list internally. It's called bucketing concept. So I'll explain that in the separate class how internally hash map works. So because that's one of the interview question. Okay, how internally map works. So for the freshers, that's really important. So let me put here one null as a key, null as a value. No problem. It'll take map dot put. Let me repeat the same thing, which is third. Third I want to replace with hive or whatever it is, map it is. Now I'm going to print these values. Null. Does it maintain the order, guys? Does it maintain the order? It's not maintain the order. No order, right? Null came, but before I have given one, but it gives me a null. Null Java J2E map reduce. So map reduce has been overridden the previous value. Previous is supposed to be JDBC, but it's overridden. And Hadoop and fifth one is Spark. Right? It's not maintain the order. It's not maintain the order. Right? Whatever the instruction order. So here if you just print all the values, you can print like this. Suppose if you want to traverse through, how will you traverse? Map dot map dot entry. What is your key? Integer. And what is the value? String. Let's say map here as well, colon map dot entry set. where is our entry set? Why my entry set is not giving here? Okay, this name and this name is accepting the same name. Let's say this one, single map or single pair. I'll say pair. Just say pair. Now it will come. No confusion because it was showing the local variable. So that's why entry set. Okay. Now here, space out. You can create. You can get the key and you can print the value. Keys. You can say map dot pair dot, not map, pair dot get key. You can print the only key. Respective value. Or else remove this. No, it will nicely display there. It will be displayed very nicely. So I just want to display nicely. Just cosmetic guys, nothing. So pair dot get value. Just print. See here, null with mapped with this, one mapped with this, two mapped with this, three mapped with this, and so on. This is the one way. So it means your map is not in order, hash map is not in order. It is allowing the null, it's allowing the duplicate, but it's overridden the previous one. So you can say it's not allowed the duplicate as well. You can say it is not allowing duplicate as well. Is this clear? Also, as I said before, entry set, if you guys remember, and if in the from this I shown you here entry set. The entry set which gives you a key value pair. Each key value pair it will get, right? In this one more thing, key set. Key set. What you can do a key set? You can get the only keys. Key set will get you only keys. Suppose you want from only keys. You want to get the only keys. You want to get the 1, 2, 3, 4, 5 and null. You can get it. You want to get the only values. You can get it. You can get it. So can't I traverse through this? Yes, you can traverse through as your iterator. If you guys have seen in the previous classes iterator, right? So what you need to do? First you need to create a set. First you need to create a set from this entry. So how will you create set? Set interface, set of keys, and what you need to do? Map dot entry set. So the set has to be from the util set. So now you have a set key sets here. All keys are available in this. See here, all entry set, complete set is there here. Now it is come as a set. See, it is a map. Now it is a set. It was a map. Now it is a set. See here, collections. It came like a set in the your bracket, right? So now when you want to traverse through this, what you can do? You can traverse through iterator using iterator. Iterator. You can use iterator here. You don't need to specify any type here because you are using set. Iterator it equal to set key dot set key dot iterator. Set key dot iterator. Iterator is meant for iterating. Iterator is meant for iterating. Iterator is meant for iterating. Iterating through each and every pair, or it's a key. And you can use while loop as similar as other things. You guys know from here. So iterate has next element, has next, whether the next element is there or not, and go and take the first element, right? You know that, right? You know that from here, right? So this is how your map works. So let me connect charging. It is too low. Yeah, not connected. Right? So what is your hash map is characteristics? The hash map will maintain the values in key value pair. It will allows the duplicates. It means that it will over the duplicates. You can say it's not allow the duplicate. It will not maintain the order. It will not maintain the order. Whatever the order you are inserting, it's not maintaining the order. So do you guys clear about the map? See here, hash map allows the null values. It allows the null values. No order, no duplicate keys. Value can be duplicated any number of times. Value can be duplicated any number of times. The only our hash functionality we are doing on respect to key. Any doubts about hash map? Any doubt about hash map? Next, remaining also work the same way. They also stores the data same way, key value pairs only. The slight difference is the way they have behaves. You have something entry set, key set, the total values you can get. You can get the only keys, right? You can also do something like this. I want to find the source of the very specific element. Keyset dot iterator dot next. Iterator. I just now explained. Iterating through. Iterating through. Right? So you can say equal you can write all your conditions like if equals ignore case, or you can write equals if this is equals and do this something different, right? So for each loop, just now I have explained for each loop. So here I'm doing some kind of small logic I'm trying to test here. If the test is that if the name is Ravi, and print this. If it's not, print other things, whether I have printed or not printed, such kind of thing. So I'm getting the specific value for the sixth. I'm checking whether its fifth value is contains or not. I'm checking Govinda is contains or not. I'm printing all values of the hash map. I'm printing all the key set. You can do that. You can do any operations on this, right? And coming to hash table, it is a legacy. As I said before, hash table is legacy, very old one. So all your vector and hash tree is the first two collections in the Java 1.2 onwards. So that time they are more worried about the thread safety. So even your hash table also is a synchronized thread safety. That time they're very secure about their application. It means they're synchronized. Each and every method they cannot write multiple. They cannot write what you call. Um, they cannot directly. Let me put in this way. They cannot directly. Uh, uh, Multiple threads cannot access in the specific. They cannot multiple people cannot put at a time. While getting, they cannot multiple people cannot get it. Multiple threads, multiple people in the sense multiple thread, right? So it is these methods are synchronized. Only one thread at a time can access, and it's not allow the duplicates as it's a functionality of the map itself. No duplicate keys, no duplicate keys. Even if you write the duplicate key, what it will do? It will override the existing one, and your hash table will not allow the null values. Null as a key or null as a value. It will not allow. It's not allow. So do you like to see? Let's see here. Okay, let me show you with the proper example here. Let me show you with the proper example. Okay, hash table. Now I'm just replacing. If I do refactoring, what will happen? My previous example also will change. I don't want to change my previous example. That's the only reason. What it is giving you? Null point exception. Null point exception. Right? You cannot enter the null values into your hash table. So, but in your hash map, it is allowed. That's the difference between your hash map and hash table. Hash table will not allow the null values. So, if you don't have a null, it will print properly. If you don't have a null, it will print properly. Understand, guys? Hash table, right? So the next one is linked hash map. Linked hash map as similar as your hash map only, no difference at all. It will just maintain the order. Whatever the order you are giving, it will give the same order. If you see your hash map and all these things, they are not giving the order which you have inserted. They are not giving you order which you have inserted. They will be in the different order. They will be changing, right? So that's the reason. Linked hash map, wherever you see linked, it means it will maintain the insertion order. So will it allow the null? Yes, it will allow the null, no problem at all. You can give the null. Will it allow the null? Yes, it will give the null. It will allow the null. And other one, tree map. Tree map. So you know the tree set. We have seen the last class tree set. What the tree set is doing? The tree set sorts the value. Tree set sort the value. It will give an ascending order based on the key. Based on the key, it will give an sorting order based on the key. The same way tree map also will sort the value based on the key. Based on the key. The only difference is it is sorted value. So let me execute this program for you guys. I'll show you why the null, because we have added null in some of the place. Okay, let's just go up. Your hash map values, this is the hash map values. These are tree set. These are the hash map view. This is the trees. This is the only keys. Only keys. Here we're printing only keys. Okay, see here, this one, only keys we're printing here. Hash map keys, hash map values, only values I'm printing here. And this is the source, like whether it exists or not. It's some if condition here. I'm just checking whether it exists or not, and I'm checking whether Ravi in the in the loop. I'm checking the Ravi's equals to any value. Is there any value as a Ravi? Yes. If it is there, it's finding the key. If it is not there, not get. I'm just printing. I'm not get printing. So the value of getting sixth value. I'm get method. I'm using the get method. I'm printing the sixth value. Contains key. Is that fifth value, the fifth as the keys contains? Yes, it is contained. True. Contains value. Is there any value which contains with the Govinda? No, it is not there. If it is not there, it's false. Why it is not there? Hashmap Govinda is there. No. Let's go ahead and check. Govinda here. Why it is not comparing? It's there. Hashmap contains value Govinda. We have, right? We will see on this why it is not printing, why it's printing false. It is there, right? So if it is there, it should print true. Why it is not this one? Contains something we are doing here. Hash map dot contains value. I will check this. I mean, there may be some why it is not printing. Both are strings, no problem. And no, it is not there. See here, if you print the values, yes, it has been replaced. It has been replaced. See here, the next below I'm printing all the values. That's why it is not there. It is has been replaced. That's why it is giving false. Right? Sometimes you'll get confused because I'm doing here, I'm replacing with multiple values here. Yeah, 666. Everything is has been replaced. Here also it has been replaced. That's the reason. Very good. Nice point, Harika. Okay, next. Let's go down, little down. And we're printing all the values. We're printing all the keys. This is all the values and this is all the keys. Okay. And your hash table, this is a hash table. As I said, hash table will not allow the nulls. That's why it is null pointer exception. It will not allow the nulls. That's why it's null pointer exception. Just comment this and go ahead and print it. Now see, all the values has been printed. All the values has been printed. And hash table contains CYA. Yes, it is contains hash table. I printed all the values. Is it in order? No, there is no order. There is no order. Linked list or linked hash map. You look at the linked hash map. 1 2 3 4 7 5 6. 1 2 3 4 7 5 6. Whatever the order you give, the same order linked hash map will maintain. Very simple. Linked hash map, wherever you see a linked, it maintains the insertion order. Wherever you see a tree, it maintains the sorting order. Wherever you see like hash, it internally using the hash code to maintain uniqueness. Is this clear, guys, everyone? And tree map. See, the tree map is giving a sorting order 1 2 3 4 5 6 7 in sorting order. Even though you didn't put into the sorting order, it is giving you a sorting order. Look at here, the line has been printed, and I have created something new, hash map. Sorry, tree map 3 5 6 4. So I given the wrong order. It's not even proper order, but it's printed in very proper order. It's printed in proper order. So you can do a sub map. From the one map, you can create a sub map. From one map, you can create a sub map. So from where to where you want to create, I have created from 0 to 7. So I can create that. I can create a sub map. But guys, one more thing here. As of now, we have seen string objects only. Not only string objects, you can also keep employees, employee map. Look at here. So if I want to keep hash map this, if I want to keep map into, I mean, employee into object, if it has to be equals and hash code. It has to be equals and hash code. You know why hash code and equals? Because to maintain uniqueness. If you didn't give the hash code and equals, it will work, but it will show you the difference. You may get the duplicated values. We have seen the last class in the dog. If you have seen the last class in the dog, so same values are there, but still dog is repeated in the set interface. So I ask you to go through the previous video one more time. Okay, so you have to override explicitly. You are telling that, you are explicitly telling that on what basis you want me to hash code, an ID, name, salary. You have to tell explicitly. And so to put your employee class into hash map, you no need to extend a comparable interface. You need to extend the comparable interface. But if you want to put your employee class into Treemap, if you want to put your employee class into Treemap, you have to implement comparable. Why? Because it is going to sort internally. It is going to sort internally. For the sorting purpose, we need to implement comparable interface. The same thing we have discussed in the previous class. So you go through one more time. Please refer that and come back and try to understand why we have implemented a comparable interface here. And all these classes, whatever we have discussed, I have added into our this one, the git. So either irrespective of fresher or your experienced, please refer the git. Git account. Git is the GitHub is the public repository where you can upload your code or where you can see others code as well. So go to the Git and search for the Veera Ravi and click on this, because mine is it will not be displayed here, but you can click on the users. When you click on the users, you will find mine. Okay, click on the users, you'll find mine. The code, there won't be any Veera Ravi with the code, so only users will be the name. So we are searching with the name. So click here and we'll be having all of my repositories. I'm going to create some more repositories for the different code, and here you have a source Java code. So Java code is the same, src com, let's say Lara. In that you have a collections, in that you have collections, employee demo, list demo, set demo, all the classes are there, okay. Please go through them and try to execute it. So I didn't give any comments, so by default it's the first comment, so I didn't give any comments for that. Okay, so that's it for today, guys. Tomorrow onwards we are going to start MapReduce. Please don't miss from tomorrow. And also someone ping in the group saying that we are going to discuss MapReduce from tomorrow.